Hello everyone, my name is Subhashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions, and today I welcome you all to this special webinar. And today's topic is Redundancy Protocols of Cisco. We'll talk about HSRP, Hot Standby Router Protocol, VRRP, Virtual Router Redundancy Protocol, and GLBP, Gateway Load Balancing Protocols. So these are the not the routing protocols that we see, but these are the redundancy protocols. Now, what do you mean by the redundancy? Redundancy means you have the backup links, the redundant or the extra links you're having in the network, and to support those links, to support the automatic failover across the link, we require these protocols. So let's first discuss the theory part. So to understand the redundancy protocols, there is HSRP, VRRP, and GLBP, and we'll explore the key redundancy protocols that ensure the network availability. Because if you have only one link, then there is no network availability because that link can always fail. So you should have some redundant links in place, say some backup links to support your network. And we'll also learn the differences, benefits, and configurations of HSRP, VRRP, and GLBP in this case. So what is the benefit? Benefit is the high availability. That is a need for the redundancy. That say, for example, you are having some servers running on your enterprise network and you are not having any backup link. You are having only one link. Say your web server is running, say your DNS is running, or the DSV server may be running. So definitely there is only single point of failure. If that link fails, all is gone. So you should have some redundancy there. And what are the benefits? Minimize the downtime of your network, critical to maintain continuous business operations because you should at least secure that there is zero downtime. Mitigate SPOF that avoids single point of failure, that is the SPOF, to improve resilience. Means that if you're having one single link, if that link is gone, your entire network is gone. Network redundancy, you have to achieve multiple pathways to ensure traffic flows despite failures. So you should have the redundant links in place or the backup links in place in order to have the smooth traffic flow always, even in the case of a link failure. Real world impact, e-commerce sites risk losing, say, $10,000 per minute without redundancy. Yes. So if you're having an e-commerce site running and if you're not having redundancy, that much you lose per minute, even more. So everything is now cloud based or IoT based. These apps, you have web apps, mobile apps running, and you can imagine the risk and the loss they may face if they do not have the redundancy. Now let's come to the HSRP, Hot Standby Router Protocol. Now this is a Cisco proprietary protocol and exclusive to Cisco device. You cannot configure it on, say, the Juniper router or in any other device. That you cannot do. And it ensures active and standby routers that I will discuss a bit later. What is the active router? What is the standby router? Active is the primary router and standby is the secondary, the backup router, but details I'm coming in a bit later. Now, second point is the virtual IP and virtual MAC. So you have a shared address represent the active router for clients. So there is a virtual router. There is a concept known as virtual router that is also I'm going to discuss in detail. And what is about the virtual IP and virtual MAC? Virtual IP we can give, but virtual MAC definitely we cannot give because we cannot change or give any MAC address. It is auto-generated. Priority and preemption, these are also very much important topics. Higher priority routers take over when active router fails. Now that is the priority. You have to assign the priority, HSRP priority, and then you have to make one router active router. And preemption is another thing that I'm going to tell you. Hello and dead timers. Yes, you have hello and dead timers here also, like the OSPF. And the timers control router state detection and failover timing. So this also you can change. Second is the VRRP, Virtual Router Redundancy Protocol. Now, this is a bit old one, and the ITF standard defined by RFC 5798. And it is interoperable across vendors, so it is vendor neutral. Uses master and backup routers for redundancy. Here you do not say active or standby or active or passive. We do not say that. We say master and backup. priority and VRID, priority based election for active router with virtual ID, and advertisements or router updates are sent every second to monitor router status. So it is like you can say the heartbeat or the hello time or the hello messages. So that is also exchanged between the routers every second. Now let's come to another very important protocol, that is GLBP, Gateway Load Balancing Protocol. Now this is truly a load balancing protocol because say the VRRP or the HSRP, it was a redundancy protocol, but it was not load balancing in true sense. In case of GLBP, it is also a Cisco proprietary protocol and it supports multiple active gateways for load balancing. Yes, this is a very important sentence because it supports multiple active gateway means that here every router is active. There is nothing like passive or standby router. Every link is active. It is actively participating in load balancing the traffic. Say 50% load is sent through one link and the other 50% is sent through other link. I'm not saying that it is a equal cost load balancing always. No, it can be unequal also, but load balancing can be done. Now there is a concept known as AVG, active virtual gateway, and AVF and AVG, it should be, I think, active virtual forwarder. AVG assigns MAC and AVG is forward client traffic. So active virtual gateway assigns the MAC and active virtual, I think it should be AVF, active virtual forwarder forwards the client traffic. So you can say the AVG is like the virtual router that you can find in the HSRP, and AVF is a node that is actually forwarding the client traffic. So these are the 2 points there, which is actually forwarding the traffic right now. That is the AVF, active virtual forwarder, and AVG can be the virtual router that is having the task of assigning the MAC. Now, what are the timers and versions? Hello is 3 seconds in case of GLBP. Hold down is 10 seconds and it supports IPv4 and IPv6. Now let's come to the comparison. What is the key differences between HSRP, VRRP and GLBP? Now first is the standardization. HSRP and GLBP are both Cisco proprietary, but the VRRP is IETF standard. That is why I told you that it is the old one. Now, load balancing, only GLBP supports load balancing across routers. That point also we have discussed, that HSRP and VRRP do not support load balancing. Scalability and complexity, VRRP scales well. GLBP is more complex due to balancing. So VRRP, HSRP, they are more, you can say, relatively simple protocol. But GLBP is very complex. Convergence all offer similar failover speeds and reliability. So convergence-wise, it is more or less same. And the configuration examples, definitely we will configure the HSRP in detail. Now, in case of HSRP, yes, you have to configure a standby router with standby, and then the group name. One is the group name and the IP, that is a virtual router IP, 10.0.0.1 or any IP. And then you can specify the priority, and you have to, like standby, again the group number, that is a 1, then the priority is say 110. So to make an active router, you have to assign the priority more than 100. 100 is the default priority, but you have to assign priority more than 100. In case of VRRP, you have to again do VRRP, then group number, say again 1 or 2, anything, and IP, the same one, so the virtual IP, and priority also the same one, VRRP 1, priority 110. In case of GLBP, so the group number is 10 and the IP is again 10.0.0.1. But in case of the other command, it is GLBP group number 10 and preempt, because there is no standby router in the GLBP. Remember that I've told you. So GLBP, you cannot make any router a standby router. So in that case, the priority is not needed. It is a preemption. Preempt is needed. Now, in the conclusion, how to choose the right protocol? Now, match needs and budget means that you have to select protocol based on network size and complexity, the scalability of a network. If the network is too big, you have to go for the GLBP. If you need to do the load balancing, you have to go for the GLBP. If you need only redundancy, you have to go for HSRP or VRRP. Simple versus advanced means that HSRP or VRRP suit basic redundancy needs, and GLBP offers load balance, that I've already told you. Interoperability means consider multi-vendor environments favoring VRRP. If you are having, say, Cisco router and Juniper router, you should go for VRRP, not for HSRP or GLBP. Now, what is the future trend? expect increased IPv6 support and protocol convergence. So yes, GLBP is very important in the future. So that is the theory part regarding this, say, the redundancy protocols. And we can actually configure one redundancy protocol here with the Cisco's, say, HSRP protocol. So here you take any router, you can take PT router or any router. So this is the primary and this is the backup. And you take a switch and also take a PC. Connect to the any link, and here also you connect the router to the switch with the, say, the straight cable. Now you can connect any other nodes here or server, or you can do routing, but I'm not doing right now because I'm only going to show you the protocol, not the traffic flow. So first give the IP. Interface F0 by 0, bring it up, and 10.0.0.1, the physical IP that we are giving. And say it's 10.0.0.2. And now say configure the HSRP. So in the interface configuration mode, there is no such command like the HSRP. If you give question mark, it will show you unrecognized command. So how can you configure? You have to configure like this standby. It is not that you are putting this route in the standby mode, but it is the configuration standby and give question mark. You have the group number, you can see from 0 to 4095. If you give the group number 0, it is always active. IP, you have to enable the virtual IP. Preempt, I'm telling you a bit later, it is about the priority. Priority you have to give, and timers track, you have to track the interface and the version. So the standby, I'm giving the group number, say 1. You can give any number, and say the virtual address IP is 10.0.0.100. And then the priority, standby, then the IP, and the group number 1, and the priority can be from 0 to 255. I'm giving, say, 110. A message should come that this is the active router, because on the other router I haven't configured the HSRP, so this router should become the active router. And the preempt means that, say, this router's interface has failed and the other router, see the message has come that it has become the active router. So I was telling you about the preempt. Preempt means that if the other router has become the active router, because this router's interface has failed, so the standby router has become the active router. So preempt means that this router will always hold the role of the active when the link is restored. So if the link is restored, and if you're having, say, the third or fourth router, any third or fourth router here in this city is connected, even then this router will become the active router because it will hold its role. That is the preempt. Now go to the router 1, standby, and the group number 1, and you have to give the virtual address IP first, 10.0.0.100, and do not need to give any priority because this will become the standby router. So in the standby router, remember the priority is by default, I've told you how much it is, 100. So the message should come that it has become the standby router. Just wait for 1 minute. Yes, now you can see it has become the standby router. And to see the configuration, you have to give show standby. So the state is standby, and you can see the virtual router's virtual IP address, active virtual MAC address. This is 00000C07. This is the multicast group. Okay, this is a HSRP multicast group. Okay, hello time, whole time you can see active router is 10.0.0.1, that is other router, and this router is local. This is priority is 100. So you can see every configuration here. And here if I give show standby, then definitely you can see that this router is active router. Active router is local. And also I can go to the interface, and also I can give standby 1, and I can give preempt. Means that this router will always become the active router when the link is restored. So first simulate the link failure. Say I am shut down the link. Yes. So the link is down. So you can see the HSRP state is now from active, it has become init. These are the states. And now the router 1 should become the active. Yes. Instantly you can see that this router has become the active router. So the role is shifted of the active router from the active to the standby. Now the standby is active. Who has done that? It is done by the virtual router. Virtual router is an imaginary router. Nowhere you can see this virtual router. It is not in physical, but it is the imaginary router. Now again, if you say restore the link, say if you give no shut and open the interface, again this should become the active router because we have given preempt. Here it is 2 router, so definitely it will become the active router. But even if there are 3 routers or 4 routers, you just give this preempt command and you'll see that this router will always become the active. And yes, it has become the active router once again. So this is a failover. When the link fails, the role, active role, is shifted towards the standby, even if it has a lower priority. And then again, if the link comes back, it again becomes active. And again, in the router 1, again it should become the standby, and the standby message should come anyway. Yes, it has become the standby router that you can see. So this is a failover. So that is the redundancy. And one more thing, that you can actually on this PC give the IP address, and the gateway you have to give the virtual IP address. Say it is 10.0.0.20 or any IP, and the default gateway is 10.0.0.100, means the virtual IP. And you can also ping that. Yes. Why? Because the PC sends the ARP request, to this virtual IP address of the virtual router. So even if this virtual router is not present here, you can see the you can also ping. You can also ping the virtual router, and also you can send the traffic. You can send the ARP request to the virtual router. So that is, I think I have shown you the theory behind the HSRP, and also I have shown you the practicals. I have configured practically the HSRP. In packet tracer, VRRP or GLBP is not supported nowadays, and this GLBP, VRRP, it is not used that much nowadays because of the automation. It is automatically configured, not the manually. But yes, these 3 protocols still are the dominant protocols in routing environment in case of the redundancy and the fault tolerance. So fault tolerance and redundancy is a very important issue in any network. Nowadays, you talk about the cloud or you talk about any traditional networking also. In respect to that, we can say that if you are not having the redundancy, then there is a single point of failure, say to the ISP. To the ISP, you are connected to only one link. And if that link fails, definitely everything is gone. Even in the ISP design, you should have dual ISPs. You should consider that you are, say, connected to ISP1 with one link and ISP2 with the other link. So in that case, that is a good redundancy. So anyway, there can be many designs. There can be dual home design. There can be multi-home design. Multi-home means there are multiple ISPs that I was talking about, that you are connected to multiple ISP. Dual home means that you are connected to the same ISP but with more links, so the redundant links. You can achieve redundancy anyway, but the redundancy and fault tolerance is important. And yes, load balancing is also important, because if you're having load on one router or one server, definitely the bandwidth is utilized more and your link may always fail. So definitely you should achieve load balancing in your network, in your router and server level. So these protocols are very important in Cisco environment, and also this is important for Cisco, say CCNA 200301 certification, as well as in the CCNP certification in the NCORE, the core consider paper. This is very much important there, and very, very detailed discussions are there in the CCNP and CCI level. So if you are going to achieve those certifications, you have to study these protocols very meticulously. So this is about the redundancy protocols of Cisco now, and I hope that you have got a good understanding of these protocols from this webinar, and you will be also able to configure it in your enterprise network, and also it will be very helpful for your future studies for the Cisco certification, and also in your job prospect as a network engineer. So I thank you all for joining and watching this webinar once again. That is all I have for you now about the Cisco redundancy protocols, HSRP, VRRP, and GLBP. And I'll come with some new topic next step. Till then, keep studying and bye.